Yeah, hello everyone. Good evening. Welcome to the week 7 live interactive session on Advanced Computer Networks course. We'll get started now. Can someone confirm if I'm audible? Am I audible? Yeah, we'll get started. Just quickly, we can quickly skim through the questions and then take a look at the topic. So basically, the topic discussed in the last week was majorly on network function virtualization. Why this whole concept of NFV came in, and what are the advantages of network function virtualization? That was the topic covered in the last week. We'll take a, quick look and try to look at in a more simpler manner. Before that, we'll just look at what are the questions, previous year's questions. Majorly, all the questions were from the NFP only. So we'll come back to these questions once again once we are done with the discussion. Before that, quickly, we can take a look like which of the following challenges is associated with NFV. So any technology comes with pros and cons. So what are the challenge with NFV? Then what is bump in the wire model? Another question is what layers of operation does NFV addresses? We'll see that. Then what is network function virtualization? Then the major, yeah, what is the difference between NFV and SDN? And I think a couple of questions were on the NFV architecture or framework. So I think we can have a look at what all that and then come back to the questions. Yeah. So I'll share another screen with that. All right. So as I said, the So the major topic covered was network function virtualization. Okay. So before getting into NFVs, let's take a look at why this whole concept of network function virtualization came in, and before this came in, how it was earlier. So we have in the previous class, I think we have already looked at the arrival of software-defined networking, wherein the major motivation for SDN was that the existing routers and switches which were out there in the network was completely coupled, and it was kind of a black box that was bringing in a lot of management overhead. Every router had only local visibility, and to achieve a lot of functionalities, a centralized topologic visibility was beneficial, and that's when the whole concept of data plane to control plane separation happened. Now here in with NFV, let's start with something called as middle boxes. Let's try to look at it from the perspective of middle boxes. So, what are middle boxes? So, a typical definition for a middle box could be like any intermediate. One second. Any intermediate box performing functions apart from normal standard functions of an IP router. On the data part, between a source host and destination host. So this is what a middle box is. So for example, we have multiple routers out there, and there is a source node and there is a destination node available. Okay. So if from the source to destination within the data path, if there is any box that is doing a function other than the function of an IP router, then we call these boxes as a middle box. Any one of you, what is an example of a middle box? A most common example is it's a firewall or a NAT device, a load balancer, a proxy. So there are many such devices that these operators place in the network as a bump in the middle. That's a term called bump in the middle. That is, this will be placed like a bumper when we go on the road, right? So the packet will come out of the router, it will get into the device, and then it will go out of the device. The end host or the source and destination have no idea of such devices are placed or not. So these devices are placed because there are certain requirements that the operators have, and those requirements are met by these devices. So typically these middle boxes are hardware devices. They are also like our earlier routers and switches, they are also highly coupled software and hardware together, and they are moreover they are custom built device. For example, a firewall device hardware will be very specifically built for the kind of rules that a firewall would be handling, or a deep packet inspection device, or a intrusion detection device, intrusion prevention device, IPS. All these devices are custom built hardware devices. Their functionalities are very specific to what the device is meant to do. So we won't be able to use these devices across. Like you get a firewall, and if we try to get an additional functionality from it, it is not possible. So they are custom built hardware devices. They are the custom built hardware devices, and since all of these middle box devices serve different functions. So, if a company or an enterprise have a network with all these devices placed across, you also, when we have all these devices placed, we need operators to maintain the network, and the operators also need to have varying set of skill set to configure all these set of middle box. So, how a firewall is configured is different. How a firewall is configured, it is different from NAT configuration. How a proxy config is different from a load balancer. So each of these devices are very different. So the skill set required to configure these devices also vary. Skill set or expertise. Majority of the time, it so happens that one operator may be well versed or expert with only one kind of a particular device. Sometimes it happens that you try to work with multiple device and mix up the configurations, and this can lead to a lot of configurations and network outages. So as the number of such middle boxes increases, the enterprises need to have more number of people to configure and maintain these things for a smooth functioning of their network. So I think in the lecture also, the professor have shown statistics if we take the for a large network, if we take the total number of routers deployed in the network, the number of middle boxes were also equally high, and there was also statistics on the number of issues, like majorly firewall was one device whose configuration was leading to a lot of network misconfigurations and errors and issues in the network. So this exists. So first thing, they are custom built hardware, so they are costly. So to manage them, we need manpower, and we need expertise to configure them, and any mistake in these configuration can have an impact on the underlying network operations. Another thing is, sometimes it so happen that you buy like a firewall from different vendors, the configs and all keep changing. So there became a lot of dependency on the vendors or the hardware suppliers. The cost shot up, and there is a dependency also. Like if you get one firewall in an enterprise, if you have a device from a particular vendor, you end up buying from the same vendor again and again to prevent all these issues. Then the upgrading, see the IDS, IPS devices, like as as time passes, their life goes down, and then one need to go for new devices or etc. Uh, that is there. Another aspect was, since these are custom built hardware, if a telecom operator finds a specific requirement to be met, so that the network operation can be smoothened, or a certain functionality has to be added into the network, first it has to go to the idea or the protocol, or the functionality has to be designed. Then before bringing it an ideation for a functionality to be brought to deployment, it took a long time. So basically, what the operators observed was, from ideation to deployment, typically the time frame was approximately 2 to 6 years, which was very, very huge. This was because uh, first the idea has to come out, then the basic testing, prototyping and all has to done. Then the operator need to go to the vendor, right? Vendor to tell that I have a so and so requirement that has to happen. Then once a requirement is told to the vendor, vendor should get convinced that okay, this is actually needed. If we bring up such a device, people will be consuming that device. So that has to happen. Then when there are some standardization that comes into picture, and then the actually the hardware uh, design and hardware development will happen, and then the vendor will sell it in the market, then operator will buy it and deploy it. So there is a so from the telecom operator, telecom operator, the idea goes, then the vendor, equipment vendors, they get lot of requests comes from different operators. Then they should feel that okay, this has to be built in. Then they go for the standardization. Then they go sell it in the market, and that is when the operators buy it and deploy. So this whole cycle was actually taking a lot of time. During the same time frame, probably in the 2011-12 time frame, around a decade ago, when the this majorly happened during the boom of this 3G, 4G, two, 3G, 4G, 5G. That was when the this a lot of earlier with the 2G and all the devices in the telecom operators used all custom hardware devices only, and they felt the need during this time frame. And when they looked at the cloud providers like Google and other giants, the service providers, they were able to come up with new ideas and put it into production, have work on it, build the software application, put it into production, deploy, and then in it took maximum 6 to 8 months or maximum in 1 year's time. That was the ideation to availability time frame for the service providers. Whereas with the telecom, because this custom built hardware vendor dependency and all were there, it was taking a lot of time for the ideation to deployment. So this was actually one of the major reason why this whole concept of virtualization came into picture. That is when the operators sat and they started thinking about, like, is it possible, can we also bring in the same mechanism, like how the service providers like how the service providers do, can we also bring in the softwareization into picture? Okay, so that was the start of network function virtualization. So basically, the intent was here, as we see, an idea has to become a hardware, and then it has to be deployed. Instead, can an idea be deployed on a virtual hardware? Is it possible to utilize the existing custom hardware, available commodity hardware, off the shelf hardware? So is it possible to use off the shelf commodity hardware and run the functions? So this is what people were looking for, okay? And the answer was yes. That's how the whole concept of network function virtualization came into picture. Any doubt till now? So the whole idea with network function virtualization is like we have this route, we have the content distribution, a network, another, we have a firewall, then we have deep packet inspection, one box, we have another box with NAT. So this is all the existing, okay, middle boxes. With network function virtualization, what we were trying to achieve is we will have commodity off-the-shelf hardware that will have compute, that will have storage, that will have network. And we will be running these as, this is like a virtual router, a virtual CDN, virtual DPI, virtual firewall, virtual NAT. So this is the whole idea of network function virtualization. So instead of having the software and the hardware clubbed in a single device, can we implement the functionality? So we know what firewall does. Firewall does looking at the incoming packets flow type. What does a firewall typically do? Or simply, let's take a NAT. What does a NAT do? It will translate the input IP, input private IP to public IP, and reverse. When on outgoing direction, private IP to public IP, and in the reverse direction, it will translate public IP to private IP. So this is the functionality that the NAT does. So we can, of course, develop a software that does the same functionality, right? So that's what we are trying to do here. So whatever functionality that the box does, we are trying to have an implementation in the software. So like an application. So firewall will be available as an application. What does a firewall do as a function? So firewall will look at the various, look at the flow ID of the packet, check the rules, and then take the action based on the configuration done, right? So this can be actually achieved in a software also, right? I mean, some very naive example could be you can have a simple table implementation in a software. In that table, we can give the firewall configurations. So when a packet come, we can look up to that table which is implemented in the software. We have already seen, right, how in the software these try implementation and all. Routing table implementation in software using tries, optimizations, and all that. So we can have the firewall logic implemented in software in any of the programming languages. We develop it as a software, and then this functionality that the box will achieve, the same functionality will be achieved using firewall also. So here the concept that we use is, so we build an application, then we have to deploy it. Where are we going to deploy? So earlier how it was that we had a hardware, and inside the hardware, so earlier we had the firewall, we had the software, and we had, I mean, in the hardware we had the firewall logic, and we had the hardware, right? It was a closed system. Now what we have is, we will have the firewall application, firewall app. We will have the app, and we will deploy it on top of a virtualized commodity off the shelf hardware. Okay. So when I say virtualized commodity of the shelf hardware, it could be in a virtual machine, or it could be deployed as a container, or in any of these manner we can deploy this application. Okay, so hope you are able to understand the difference between a box and the virtualized when we do it in a virtualized manner. Any queries? So when we do like this, as we already saw, this hardware based, the earlier middle boxes were expensive. It was static. Once the firewall comes with certain functionality, that is all we were getting in. It was difficult to customize it, or for example, it was not flexible. That is, we had the like whatever the vendor provided, that is the functionality that we could get. If my enterprise wanted a specific additional feature, there was no way I could get that in the firewall. Whatever the vendor was providing is what we get. Whereas when we go for the virtualized network functions, since these are software, bringing softwareization always brings down the cost. First of all, because these are not specialized hardware, these are off the shelf commodity hardware, so this becomes less expensive. They are more dynamic, status. If we need to we can as we are deploying these middle box functionality in the software, it is very easy to increase the number of instances that I want. Like currently I have one instance of the firewall application running. At a later point, if I want one more instance, it was very easy to scale up or scale down. But whereas in case of hardware, it's not possible, right? The procurement cycle itself takes time, and firewalls are not cheap. So it's in lakhs. So we buy a box, and suddenly if a requirement comes that okay, we need to have one more firewall placed at so and so, I mean, it's a very random examples. Okay, we need one more such middle box placed in a certain place, we need to again go for a procurement. Whereas when we are doing it in the software, we already have the application, we just have to instantiate another instance, that's all, and we are good to go. And then it is more flexible, because I mean every when now every telecom provider can give the specification, and accordingly vendors will provide feature rich functionalities. Like it's very easy to customize for the telecom providers also. Like if a certain feature, a particular telecom operator want a certain feature in the firewall or NAT or in the CDN function, it's very easy to put up a request to the vendor and add in that functionality, which was not possible in the earlier scenario when we were using hardware based uh, middle boxes. So these are the major advantages that brings in with respect to network function virtualization. Basically, when things comes in the software side, right? We try to run a lot of things in a same server. Uh, More control and management comes in. It gives more flexibility and what to say, more control over the configuration and other aspects as well. Because software came in, the abstraction, the how you can configure a firewall, how you can configure the NAT, more it can be more abstracted, and it made the life easier for the operators when the network virtualization happened. Yeah, so typically, I think you all are aware of this concept of virtual machines, right? Yes or no? Should I touch upon that? Did everyone use a virtual machine? You can respond, you can unmute yourself and respond back. Have you all used a virtual machine? How many of you have used? Or else I can quickly maybe show you how it works, what a hypervisor is, and all that. So basically, the concept of virtual machine is we have, let's take the simple example of our my laptop, okay? Okay, I mean, you can respond if you are aware of virtual machines, if you have used one. Sorry, the voice was not clear. Sorry, I didn't get you. Okay, I'll quickly touch upon that topic. I'm not sure if it would be redundant, but still. So let me take a simple example of a desktop machine wherein I am running a Windows machine. Windows machine. Okay, in earlier days, like before this virtualization came in, we used to have our laptops or desktop machine mostly dual bootable. We used to keep Windows as well as Ubuntu because majority of the times the lab experiments and all will have to be done in Ubuntu machine. And working wise, we used to find Windows easy to work with. So we used to have this dual boot machine wherein we will have both the operating system installed, and then whenever we needed it we used to log off. So with the dual boot, what the problem was, we have to log off and log in and then log into the other machine, so it typically takes a lot of time, right? Then came this concept of virtual machine. So what happens is, if I have a Windows laptop, I have a Windows laptop here. This virtualization concept allowed to installed a Ubuntu virtual machine on my Windows machine. So this is, if assume that this is my Windows machine and this is the x86. So we have something called as the hypervisor here. So this is the software that enables virtualization. So this hardware that is available underneath the x86 processor, the memory, everything. This hypervisor will virtualize and give a virtualized view here of the memory and all that. And on using these virtual resources, we can instantiate different virtual machines in this one simple. So this could be VM1, VM2, VM3, etc. So this is how typically virtual machines work. So though I have one maybe 4-core CPU, so I have 8 cores minus 8-core CPU. So my Windows will utilize 4 cores, and if I'm spinning up this Ubuntu VM, it will use the other 2 CPUs. and this whole Ubuntu operating system is installed, and then it will, whatever 16 GB RAM I'm having, I will, when the VM comes up, I allocate a portion of my RAM also, and using that RAM, maybe 4 GB or so it will use, and using that 4 core and 4 GB RAM, my virtual machine one boots up. So I have a Windows machine, and within my Windows machine, also have the Ubuntu running. So if I want to quickly go and do lab exercises, I don't need to log out of my Windows and reboot and come back. I can quickly go to the VM, spin up the VM, and utilize it. Okay. So if you have not used, I can just quickly show you. So because this whole concept of virtualization is built on top of the underlying hypervisor and virtualization. If you don't understand that, it will be difficult to get this concept. So maybe I'll quickly show you how it is done. Okay. So can you see this software here, Oracle VM VirtualBox Manager? So this is the hypervisor I am using, and I am now booting up a Windows Ubuntu 22 in my Windows laptop. Just put that up. So if you see, so this is a typical Ubuntu machine, right? So this is the terminal. Now, whatever we want to do in the Windows machine, I can do, and I can, and this click here. This gives me my Ubuntu, and go to anything else. Like I have my PPT here, Windows here, every other like Edge, everything. The Windows laptop is available on top. I have this Ubuntu VM, right? Putting up memory is slow. So that was just a quick demo. So this is what we call the hypervisor. VMware, Oracle, VirtualBox are hypervisors. that allow us to run a different operating system on top of an existing host machine. So if you can see here the settings of the machine. So when I am bringing up this machine, if you go and see in the settings, you can see how much advanced system, how many processor I have asked to take one processor. So we can change that. Okay, so how much of storage. So these details we can set, and accordingly whatever we are setting from here, underlying hardware resource will be utilized, but hypervisor takes care of virtualizing and providing the API for this machine to use them. Okay, so what changes? It should still submit. Actually, so I need to do some cleanup in my laptop. All right, so I hope you got some idea what virtualization means. Yes or no? Okay, now let's get back to our discussion. Just give me a minute. Just hold on, let this boot up once. Can open the fiber. Yeah. So the terminal is up. Okay. Now, like we are discussing about network function virtualizations, right? So when we say so in the lecture, you would have seen that there is a already if you had gone through the architecture diagram, there is a network function virtualization NF. I forgot that. Yeah, the one that takes care of underlying virtualizing the underlying hardware, right? Then on top of it, we have the virtual network functions that are running. So we can run those network functions in such virtual machine. So this is one virtual machine. This Ubuntu that I have brought up is one virtual machine. It's in a laptop, so based on the capacity of the laptop, we can support one or two or maximum three at the same time. But when we talk about commodity off-the-shelf hardware, they are high-end servers with 200 or 300 core CPUs and all. They will be supporting n number of virtual machines. So in such virtual machines, we actually run these network functions. Okay, so when one can run it in like in virtual machines, or another possibility is we can run it in containers also. That's a different concept. Okay, So yeah, so this is one as I think I'll switch. Yeah, as we saw here, so I just brought up one VM in the laptop. So the host machine was a Windows and the VM was Ubuntu VM. So in these VMs, we can actually run the network functions, the virtualized network functions. Okay. Yeah. So now let's get into the yeah. So how it will work is, so we have something called hypervisors. And here we will have the hardware actually, the CPUs, the memory, high volume storage. We will have commodity storage and hardware, and these hypervisor will take care of virtualizing the available actual hardware resources and providing it to upstream virtual machines. So we will have the virtual machines, so virtualized network functions running here. Network functions running here, and all these virtualized network functions could be from like NF1, it could be NF2, NF3, NF4, etc. And all these network function could be from 111 vendors, from different vendors. It could be, and they will be running using the underlying hardware resources via the hypervisor. So the Hmm. So, with this network function virtualization, so the standards body came up with some certain framework requirement and a standard architecture and all. And now, such that everybody can work on similar lines. When a standard comes up, it becomes easy to work on it. So when there are certain requirements that have been set out with respect to NFE framework. One is it that uh, one it must be the NFVs must be uh, when somebody come up with a network function, a virtualized network function. Okay. The requirements are it must be general, it has to be portable, then it must be performant, then it should be secure enough, etc., etc. The energy efficiency requirements are there. There are certain service assurances are there. So when someone is converting a network function to an NFV, there are certain aspects laid out by the standards body that needs to be met. Okay. Then typical simple architecture of an NFV is like as we have been telling, we have the underlying commodity compute, we have the compute, we have the storage, and we have the network. Okay. Then this is the virtualization layer or the hypervisor. So this will take the virtualization layer or the hypervisor. It will take care of virtualizing the underlying hardware devices. So this is compute, this is storage, and this is network. This whole This together forms what is called as Network Function Virtualization Infrastructure, NFVI. NFVI. So the NFVI. So this is the infrastructure on top of it, on top of which the network functions will run, or the virtualized or the softwareized network functions will run. Okay. So this is the network function infrastructure, NFVI. So what does NFVI comprise? It will have the actual hardware resources, the compute, storage and network resources, a virtualization layer, typically a hypervisor, and then the virtualization layer will provide the virtualized compute, virtualized storage, virtual network, and this whole thing forms the network function virtualization infrastructure. Now, on top of this infrastructure, we will have our VNFs running. Virtual network function 1, VNF2, VNF3, etc. Like that. So this could be running in a VM or in containers. Okay. So this is how the typical architecture is. Now we have the infrastructure, the underlying hardware we have, and we have the applications also. The software is also there. Okay. Now we just cannot allow it to run like that, right? We need to manage these network functions. We need to map how much resource we need to give for each of these virtual functions. We should be able to configure them and get the whatever is required, whatever output we want from the NFE that we need to get, right? So whatever output I want from the network function using the underlying infrastructure, that needs to be attained. So for that we need something called the management and orchestration. So that comes on this side. So there is another part also which takes care of the management. So we call it MANO, which is the management and orchestration. Orchestration part. So this is the high level architecture, like how the network functions will be laid out. For example, so first we have the commodity hardware, that is the storage, CPU and network available with the underlying servers. Then we have the hypervisor, which takes care of virtualizing the entire hardware resource and then provide a virtual resource. This all three of this together forms the NFVI, the network function virtualization infrastructure. So on this infrastructure, the network functions will be running. Okay. So on the infrastructure, network functions will be running, and to configure and orchestrate the functions, we have another management and orchestration MANO here. Okay, this is the high level overview or architecture. Okay. A more elaborate architecture is okay. So this is a high level idea. So now, if we have yeah, so now let's get into the framework, another HC NFV reference architecture framework. We'll take a look at that because couple of questions are from that particular reference architecture. Okay, HC, this is the standard body NFV reference architecture. So this follows the high level architecture, but there are some additional components also available here. So yeah. So the NF, so we have the NFVI here. So we have compute, storage, and network. Then on top of it, we have this is the hardware infrastructure. This is the actual hardware infrastructure. On top of this, we have the virtualization layer. On top of it, we have the virtual compute. Virtual storage and virtual network. And this forms the NFVI, network function virtualization infrastructure. Now, on top of this, we have our VNFs. So we have VNF1, we have VNF2, we can have VNF3, etc. Okay, and VNFN. So in this architecture, there is one more component which called EMS1, EMS2, EMS3, EMS4, which communicate with VNF. Okay. Then in the management side, there are multiple components. So we have first something called VIM, which will virtualized infrastructure management, which will talk with the NFVI. Then we have VNF managers, which talks with the VNFs. Then we have the NFV orchestrator. So these are the major component. This remains the same, like as we discussed. So an addition here is with respect to this EMSI. So EMSI is element management system. Okay. EMSS element management system. So what EMS does is it is responsible for the configuration of each VNFs. Like we have a VNF which we need to tell how much storage it requires, how many cores it requires, how many instances of the VNS we need to